This evening, Helen Kim joins us. I think it's somewhat ironic that somebody who's in the semiconductor and nanotechnology, which is what you normally assume is part of Silicon Valley, has actually come from Boston, from the Northeast to join us today. So I know that you all will give her a big welcome after we have her introduction. I'm so happy that Rahul Shah is going to introduce Helen. I don't know if anybody knows Rahul. I like that. You already have some notoriety. But this was my favorite thing about Rahul. I was looking up a little bit on him. He was super psyched to come to Cal. Made me very, very happy to see this. I think this is from Facebook. Is that right? Are you still on Facebook?
I still am.
Oh.
I'm not sure if this is working.
Hopefully it is. And if it isn't, you can use this one. And I'll let you go ahead and make the introduction.
Yeah, for sure.
Oh, it is now.
Testing?
Yeah.
Okay, I think everyone can hear me. So go Bears. I'm really excited to be here today to introduce you to Helen. But before I do that, let me tell you a bit about myself. So I'm an undergraduate here in my second year studying computer science. And the reason why I wanted to introduce Helen, I volunteered to do this. And the reason why I volunteered is because my experience at Berkeley in like the computer science division, it has been mainly focusing on like studying like Wi-Fi, networking, communication networks. Like not only do I do research, but I also, I'm a teaching assistant, undergraduate student instructor for Berkeley's upper division network communications class. So when I saw like Helen's experience, and I was like, oh my God, this is so cool. Dr. Kim has like, she did her undergraduate in UCLA in California. Go Bears. Yeah, we can say go Bruins. We're friendly. Yeah. And she did her PhD at Columbia, and she's worked at MIT, like Bell Labs. She has a lot of experience, and from like nanotech to being a CEO of a company that was acquired by Max Linear which is evaluated at $4.7 billion. You can see all of her experience here. I know we have a lot of EECS majors here. You'll be happy to hear that Dr. Kim was also an EECS major. So maybe a lot of us will have stuff in common, but even if you're not technically acquainted with like nanotech, like integrated circuits or any of that sort of things, even if you're not like me, I'm sure you'll still stand to gain a lot out of this. Everyone, please welcome Dr. Kim.
Let's see if the technology works.
Yes. Here we go. So hello, Cal. How is everyone? Good? Good. I'm so happy to be here and see you in person. I did so many of these Zoom talks, so I'm excited to be here. And thank you for inviting me to share the story and the story of breakthrough research technology to mass markets. I had pleasure of visiting Kushal's robotics lab earlier today. And I always love the energy, the passion of campus, the research labs. Long time ago when I was an undergrad at UCLA, not many people agree that I should pursue EE degrees. See, I'm an immigrant from Seoul, Korea. I did not grow up building computers. I did not grow up coding. But fortunately, I had very supportive professors, mentors, who encouraged me to pursue my passion. And my passion is discovery, building a team, and finding home for technology. So You guys are in the middle of Silicon Valley, so you hear a lot about startups, the challenges, the risks. And this is the story that I'm going to share is a story of my last startup, NanoSemi, which had a perception of very high risk. I'm a first-time CEO. I'm a female CEO. I'm an Asian female CEO, first-time CEO, and bringing really hard technology from research to market. Nevertheless, we persevered. We built an incredible team, and we solved the roadblock of 5G base station radios. And what I'd like to point out is 3 examples that I believe that are very critical, at least to me, or to the journey of startup, NanoSemi. I hope that you'll be encouraged to start your own and at least have the entrepreneurial spirit. So I spent, as Rahul said, a decade at Bell Labs research and a decade at Lincoln Lab, pushing the limits, technology limits. But I've always looked for ways to transition the technology that my team and I have developed to products that business units may need in the future. So in 2000, I had an opportunity to lead an engineering team of a Bell Labs spinoff called Aerolite. We were building 120 gigabit per second, 36 parallel channel optical transceivers in a small form factor. It was a monumental achievement in technology breakthrough and product development. But the target market changed rapidly. If you know, you probably don't know, around that time, the dot-com boom became dot-com bomb. And we did not adopt quickly enough to transition to new reality. So after Aerolite, I decided to go back to research, but not just pure research, but research with the goal of productizing something new and unique value. So I joined Lincoln Lab in mid-2003 to start a new effort to bring a small form factor system for intelligence and defense applications. So I was very fortunate to assemble a team and build an infrastructure to design, test, chip, and module. And my team successfully completed the prototypes, and we delivered to government agencies and so on. So the problem we were solving was this. It's receivers like that can detect very small signal in the presence of very large interferers. So in the electrical term, it's 80, 90 dB difference in signal, or 100 million times difference in signal. You'll need a very, very linear systems. Now, that sort of systems is typically a rack mount equipment. So it fits in a large space or jumbo jets. And we were tasked to find a way to put them in a small UAV or drones. So the only way you could do that is you have to build that all integrated into a small silicon chip, a CMOS chip. But if you know CMOS, right, as the voltage scales with nanoscales, the power supply is 1.2 volts. Now it's about 0.8 volts. It's very hard to make a very linear circuits with that sort of power supply. So we are hitting the physics limits, and I had to find a different way to solve this problem. So I started collaborating with a professor at MIT. His name is Alexander McGresky. He is known for nonlinear dynamic systems. So what we did was we designed for the lowest noise, and then we solved all these nonlinearities with algorithms digitally. So we were able to solve this problem of delivering the 80-90 dB of spur-free dynamic range over gigahertz of bandwidth. So we said, okay, there's all this interest from the defense community, but there was no way of transitioning to them because Lincoln Lab is a government-funded laboratory. So only way I could do was I had to leave and start my own business. So the journey of my entrepreneurship began again. So I incorporated NanoSemi in January 2014, and the name was supposed to capture the challenge we set out to solve. When semiconductors are miniaturized to nanoscale, they become better for digital, but terrible for analog and mixed signal. And we set out to compensate that with algorithm. So I had to figure out how to start a business, right? I delivered a technology solution, but it was not a business. So I had to learn. I read lots of books. I talked to lots of people. And here are some of the questions, right? You guys probably heard all of these questions before. So how do you imagine your breakthrough technology will be used by millions or billions of people and change their lives? Is there an existing solution? Is there anything wrong with that solution? Why is your discovery going to revolutionize the industry and market? And what is the target industry and market? And how big is that market? And how is your product differentiated? How much can you charge for your product? And how much will it cost you to make your product? And how many likely customers are there in the target market? So these are all these questions, right? You have to think about. So let me clarify one term here, the definition of market, since I am using the market with customers interchangeably. I'm using the definition by Jeffrey Moore. I'm sure you guys might have read his book called The Crossing the Chasm. And it is a market. Market is a set of actual or potential customers for a given set of products or services who have a common set of needs or wants and who reference each other when making a buying decision. So meaning when you bring something out, if there's only one, then that's not a market yet. But if you have multiple customers start referencing each other, now you have created a market. Okay, going the other way. So I thought, all right, I figured it out. Here's a revolutionary new chip with really low power, high linearity, because we have a new way of overcome the physics limitations of RF analog mixed signal performance with algorithms. The algorithms are based on new ways of training, modeling, the nonlinearity that resulted, and compact and accurate model. So we even had a sample showing its stellar linearity performance, even though it was for defense application. So I reached out to head of business, CTOs, other people, potential customers in the base station market. And I listened to their feedback. And the feedback was unanimous. They loved the algorithm, but not the chip. So, poof. I even had a term sheet from a VC. But the feedback was that they said the tier one equipment vendors like Alcatel-Lucent, which is now Nokia, or Ericsson or Huawei, they cannot rely on a startup to deliver and guarantee the network reliability. So I had to figure out whether, is this the battle worth fighting, or should I change the course? My entire assumption is just thrown out. So the telecom is $1 trillion market. And within the telecom, our addressable market, which is the base station radio segment, is about $100 billion market. So unlike today, where O-RAN can allow new entrants, at that time in 2014, there were about 3 or 4 major players, and they had a closed system. And interface was closed. No new company could get in easily. And there were 2 transceiver suppliers. It was ADI and TI. And they spent many years, many millions, $100 million to get into that space. So most established players and market leaders do not take risk, especially adopting a radically new approach from a startup. So I'm asking to myself, is the base station a wrong market? So I went back to my advisors, board of directors, discussing, brainstorming, explaining what I think. And then after much thought, we decided to change our direction. No chip, no base station. Now what? So we decided to focus on the algorithms. So how do you sell the algorithm? What is the business model of selling an algorithm? So we had to find the fastest path to get validation on a new product and business model. So we started with a test and measurement market. So why test and measurement when it's not really a fast-growing market? Well, test and measurement market is a market that values high performance next after the military. And they were also preparing for the base station and cell phone markets because they have to provide all the testing. So it was a good entry point. And also, every test and measurement market has CPUs inside the box and the software driver and the library. So we package our algorithm into a software so it will run in the built-in library. And the license model was a software download. And we were able to find a tier 1 OEM, and the first target was something called a digitizer and a signal analyzer. You probably use that in your lab. It's a multi-gigasample per second, 14-bit A to D converters and amplifiers inside this test equipment, and they could not meet the dynamic range, specific dynamic range of 80 dBc at that time. So we enabled our very first customer to achieve that performance and win their customer. We set up test benches to validate and help with factory testing at a tier 1 test and measurement. We hand delivered the software. So this was January 2015, 8 months after we changed the direction of NanoSemi. So therefore, we were able to validate the need of the algorithm with at least one tier 1 test and measurement OEM in a reasonably sized market. So after the validation with the test and measurement company in this market, we decided to try the base station again. So again, how do we sell algorithms? What is the business model for base station? So I go back to this question of how do we really identify the real problems that the customers in this market has. Again, how do we sell algorithms, base station OEMs, and what should be a business model? So I go back to the challenge of a base station market I've mentioned earlier. It's an old, established market dominated by 3 to 4 major players. So how do you engage with these behemoths? We learned that tier 1 OEMs were rushing to develop and deploy 5G base station radios. And the Chinese OEMs were trying to be the first in the market. So we went to China. But what are the real problems in developing 5G radios? You can read about the problems, the challenges in papers, but until we engage with customers, we do not know the real intent of the problems. Even if the customers tell you the problems verbatim, that's not what you can do right away. You need to think about what you have to anticipate what they need in 3 to 5 years' time as a product. So let's see. So what are the challenges of 5G radios? "5G, you hear all the time, is 5th generation technology standard for broadband mobile network. In order to provide more data and data throughput, 5G frequency bands are wide bandwidth. So 4G radio, you see around here, 2013, 2014, 2015 is about 20 megahertz, 40 megahertz. The 5G radios have minimum of 100 megahertz, and now 400 megahertz in some mid-bands. So many years, only the frequency bands around 1.8 gigahertz, 1.9 gigahertz in US, 2.1 gigahertz, 800 megahertz were available. But after LTE, over 50 plus frequency bands were allocated below 6 gigahertz and many more in millimeter wave bands. So if you look at this span of 10 years here, the bandwidth has grown 25 times in that time period. So I'll touch more on this, but the power amplifiers used to amplify and transmit large power to smartphones and other devices have transitioned from silicon-based LDMOS to gallium nitride technology. So this is kind of a busy plot, but what this is it's showing the power efficiency. So power efficiency is how much you're putting out in power versus how much you're supplying in DC. And there's another term called power added efficiency if you're also including the input power. So you can see here why power amplifiers have transitioned from LDMOS to GaN. As the RF frequency moves from lower frequency RF frequency to 2.6 and 3.5 gigahertz, the power efficiency is dropping. And the LDMOS is more than 10% or more worse than the gallium nitride. And these are a collection of typical product grade performance of Doherty type power amplifiers, not other configurations in the lab. So interestingly, the price of GaN PAs have gone down significantly over 7 years period. And of course, the prices go down because of the market demand and the market pressure. So this plot also has gas PAs, and they are typically used for smartphones that you hold, both for cellular and Wi-Fi routers, and indoor small cells, where cost is very sensitive. So in other words, 5G was pushed the radio technology to be wide bandwidth, higher frequency, But 5G also introduced something called massive MIMO. So MIMO stands for multiple inputs and multiple outputs. It also had beamforming. And massive MIMO, first target configuration was 64 transmitters and 64 receivers. So just as a comparison, the 4G macro had 2 transmitters and 2 receivers, or 4 transmitters and 4 receivers. So you could see the challenge, right? It's a significant increase in MIMO with the added feature of beamforming and wide bandwidth. So all of these resulted in very high power dissipation. So when you drive by highways, you see, right, those rectangular box up on a cell tower. They are base station radios. They're called remote radio head or radio units. And if this radio dissipates a lot of power, it'll require additional heat sink and additional cooling, not just the air cooling. And this will add significant cost and the weight. So it is dangerous and costly to carry a heavier load up the tower. So there is a strict mandate on the weight. So therefore, it became an urgent problem to solve the power dissipation and the cost to deploy 5G. So difference of 10% in power efficiency between 50% GaN and 40% LDMOS for, let's say, 64 of 5-watt power amplifiers was several hundred watts, was what we were talking about here. So let me take a moment to show you a simplified block diagram of a transmitter of a radio. We talked about power amplifiers inside a radio. So wireless signals are typically carried out at high RF frequency, whether it is 3.5 gigahertz for 5G cellular, 5 gigahertz for Wi-Fi, or 28 gigahertz for 5G millimeter wave. And all the modulation, demodulation, error correction, and so on are done at the baseband. They are converted to analog signal by digital to analog converter, and then up converted to RF frequency. The transmitted and received signals must be clean and occupy only the allocated band, the frequency band, not its neighboring channel. So we know the power efficient amplifiers and circuits and data converters and so on are nonlinear. So they do not neatly occupy only the channel, allocated channel. So therefore, a linear amplifier or other circuits consume a lot more power. The power efficiency is much, much less than 40%. So if you look at the typical theoretical, right, number of class A amplifiers, only 25%. So a technique called digital predistortion has been used to restore the linearity of circuits for nearly 15 years. In addition to what we call DPD, there's also a function called cross-factor reduction to control the peak to average ratio of no FDM signal while minimizing the damage to the in-band signal. So what is the big deal about CFR and DPD? So what we call as a linearizer. Well, it determines how power efficient the radio can be because it can clean up the spectral leakage created by nonlinearity of the power amplifiers and other circuits in the signal chain. It updates the coefficients based on the feedback signals from the PA. Therefore, it must be stable and robust under any conditions. Otherwise, a malfunctioning DPD can stop a radio from performing properly, and not a good thing if you're relying on a very robust and reliable, stable network. So it turned out a newly introduced GaN PAs with charge trappings, thermal fluctuation, especially of a wide bandwidth for a large signal characteristic were a big problem for the base station OEMs. Let's see. And the DPD that was typically used was based on the technique called memory polynomial or generalized memory polynomial. But the GAN PAs or highly nonlinear PAs, they do not exhibit polynomial behaviors. So having a large order of polynomials to represent the nonlinear behavior of was inadequate and required a lot of coefficients to update. So instead of blindly trying out many different combinations of terms and polynomial terms, we had a process of identifying the nonlinear terms and representing the appropriate mathematical terms. So the result was
Helen, can I interrupt you just for a moment with a question?
Yeah.
I could be the worst or the best audience, I'm not sure, because I don't have a technical background, and I don't know that everybody does.
Yeah.
But you're talking to customers and their government people, and maybe they do have a technical background, but like, what do you say to them if you're trying to explain in, like, I'm sorry, dummy terms, what it is? I understand that you're making things more efficient, but if the person across you on the table doesn't have as much of a technical background as you do, how do you explain what you do?
Yeah, so it was, so it's a different level of, the very first time that you go there is, okay, I am solving you, right, the problem of power and the weight and the size. I think that's what I was trying to say, right? That I have these radios people used to build just 4x4 or 2. Now I have to put 64 of those. But my weight constraint to go up the tower did not change. So what do? Right? You have to, and also at the same time, because your data throughput is increasing, the bandwidth became much, much wider, right? As I said, it's 25 times bigger. So what do you do in that case? So that's why they transition to this technology called gallium nitride, which is more power efficient, at least for that wide bandwidth. But it had all these other exhibiting behaviors, right? Charge trapping, thermal problems, all these problems that you see in the devices. And people said, okay, we're going to throw in more and more terms in this technique called digital prediction. It's a gigantic matrix, right? So how do you explain to these people that I have a different way? Now, if I were today, it would be much easier because I could just call it machine learning. Then magically people say, wow, you do that? That's great. In 2015, nobody used that term, 2016. So I'm trying to explain, okay, I could see these nonlinear terms, and we have a way of capturing what you see, identifying those nonlinear terms, and I'm writing this in a different math terms than what you typically write in polynomials. That's what I was trying to explain. And then they'll say, sure, nobody believed me, right? Show me. That's kind of what happened to many of these cases, right? These are, as I said, behemoth, tier 1 OEMs. So, and then the other technique was, if you have gigantic matrix and you're trying to update the coefficients, you have to invert the matrix. That's the technique. Well, that's a huge crunching of processing. And so here is the power constraint on the PA, here's the current constraint and the baseband, and you're trying to put all of those at top tower, right? So you have to solve the problem of PA and you have to solve the problem of processing. So we did, but we now had to prove it. So here's a photo. And this photo was our first trade show. In San Francisco, there was IMS. And it looks like a lab bench, right? And we had the cheapest booth there, way in the back. And our investors, Amish Devati on the left and Ray Stater on the right, came to support us. Amish is a serial entrepreneur in Silicon Valley. Ray is chairman of ADI. He was chairman of ADI and founder of ADI. So, we are putting out there, and we actually had so much crowd in that booth. How? How do we draw so much crowd? So, let's say our booth is that small and we are taking up like this much space. How is that possible? Well, we were demonstrating 200 megahertz instantaneous bandwidth for 5G radio, and with the gallium arsenide power amplifiers, with ADI's transceivers and Xilinx FPGA that these tier 1 OEMs were evaluating. And we found out that they were not able to achieve the performance to meet that 5G requirements that we were demonstrating. So word got out, right? That, okay, here's a little startup who's demonstrating what we thought was not possible. And we knew why it's not possible, because of the way they were doing. So that's the demo. But it was one thing to draw a crowd and have a publicity. And of course, we did that because Ray and Amish brought in also Thomas, who was at the time VP of sales at the Analog Devices. So he knew the people in the industry. So all these people came. But how do you convert that to revenue? So 2016 turned out the year that Chinese government decided that they are going to be the winner in 5G. So they were doing a pre-trial for 5G. And so as you know, there are 2 tier 1 OEMs in China. So one of them asked us so that they can beat the competition. So at the end of 2016, we went on a trial with them and helped them win that trial. With that, again, the words got out. So the slow and reluctant, the European OEM came to us. And we implemented this linearization solution, poured it into FPGA and chip, and it's been in the field for 3 years, and they continue to deploy the radios with our solution. So in 2020, about 680,000 new base stations were added. So if these base stations did not apply any linearization, it would have consumed 3.6 gigawatts of power. And if you use the conventional techniques, it's 2.26 watts. With ours, is 1.58 watt. So we are saving 700 million watts of power. And that's a lot of dollars in terms of electricity power cost as well. So we brought that to the market, and we enabled base stations to meet the thermal requirements, size requirements. And now as part of MaxLinear, it's implemented into MaxLinear's radio chip. So many more users around the world can use it. So now we also apply that to cell phones, satellites. And for cell phone is a bit different. Their concern is more about how to reduce the memory storage of so many different coefficients. So with real-time adaptation, you could avoid all of those. So I so far mentioned the pivot and identifying real problems. But to me, the most important, critical elements of my journey was actually the team. So I'm very blessed with the team, and I could not carry it out the startup without my team. So what you see over there, so let me just show you the picture. I started out in my garage over there, and when the truck driver of the testing equipment, Keysight, came by, said, "Oh, I'm sorry, I think I have a wrong address. I only see houses." No, you have a correct address. So my son's there trying to open up those boxes. And then when we turned on the oven, it was drawing so much power. No circuit breaker can hold that much current. So it was dimming the lights. So when we closed around, we found a warehouse, and I was so happy. And then these are Sasha, Kevin, Mike, and Jan. Jan, Kevin, and Sasha are co-founders, and they were opening the boxes with me and setting up the lab. Jan is a fresh PhD graduate at that time from MIT, and then Zoab also is a fresh PhD graduate, just joined. So we are all excited to get this started, and I spent many hours. And the reason I put my family photo there is I traveled all the time. I was recently renewing my passport. There were only 2 pages left without stamps of border control. So if I continued traveling past 2 years, I probably had to insert new ones. And of course, I couldn't have done without insightful and visionary investors and advisors who taught me about business. And of course, we had a lot of fun along the way. So the team and I grew together for the past 8 years, and I'm very grateful for them for what they have done. And I'm very sad, actually, that today is my last day at Max Linear. But I'm also very excited about the possibility of what's next. So I hope to hear from you. I hope to hear that you have started a startup and you decide to launch a startup. So my message is pivot and persevere. Thank you. Thank you for doing that. Sometimes I go off and go on about technical stuff.
Well, I actually think there are a lot of technical people in the audience. I just happen to not be that person. So I know we'll have some questions, and I'm wondering if I can get 2 volunteers to help me with the microphones. And you can walk around a little bit. Thank you very much. And I have questions, some really interesting questions from students as they're getting ready for their bigger questions. Let me just get the other microphone out. Who's up for doing some walking? All right. Thank you very much, you all. I appreciate it. So I don't know if you all really heard Helen. This is her last day at Max Linear, her last day. So she's started this incredible company. She is, in the way that you're talking about it, I'm sorry to she you. I find it so interesting. We've had these other speakers come and talk about their companies, and the way that Helen talks about her company is truly the way an engineer will look at it and talk about it. I find that fascinating, and it's a big deal that today's your last day. And you'd think that someone could be like, woohoo, who cares that I have a new passport now with lots of pages to use. But I think it's so telling because the first thing that Helen did this morning, anybody have any guesses what Helen was doing at 8 o'clock this morning? I'm happy to take any guesses. Yeah, she was meeting with Dean Liu. about new ideas. She's the first speaker in a while who's actually like wanted to go look at labs, and you were in the robotics lab today at noon. So you're like already on your next idea. I apologize because I know the audio is a little bit funky. Could be because I'm in front of the speakers. But I have some questions, and I'll start with that until we get some from the audience.
Okay.
So thank you. That was really interesting, even for me. But I think this question is kind of helpful. Could you introduce some of your products used in a smartphone? And thank you for the student who submitted that.
So they are used in, let's see, I don't know if I can name the name, but it is used for the millimeter wave, actually, to push the output power further for one particular company. And another one they're building is for just small indoor wireless device. That's what they are working on.
Is it something that would be in every iPhone or every most of our phones?
It'll be in phones. Now, is it iPhone? I cannot say which one. It's
You're not allowed to?
yeah, that's right.
All right. Does it sound like Samsung? So this, I think, is an interesting question. And if it was your question, feel free to raise your hand afterwards and ask. But how much of your job did you have to learn on the spot? I think you alluded to that when you talked about reading Crossing the Chasm.
Everything about business is I learned on the job. I didn't go to business school. I have a PhD in W. So I was actually cleaning out the office, and I realized I had a stack of business books and papers that I was getting from Ray and board of directors and reading. So I had a lot of learning to do.
So if you aren't a book person, what other way did you learn? You said you use your advisors a lot. How does one do that?
So you would be asking a lot of questions to them, right? You read about it. So the most difficult things are really about a strategy, because it's a startup. You have a very constrained resources. So you have a one shot at making a right decision. And you say, out of all these customers and the markets and product options, what should be the first? So the approach we took, let's say, the crawl, walk, and run. That's what we had to strategize as well, right? The one example was, do I keep going at the space station? People also said, why don't you just build the whole equipment and doing that? I could have, but I would have spent a lot more money for doing that. So the first thing I wanted to do was prove the essence of what we are differentiated and build on from there to expand.
So you said something kind of interesting. So please interrupt me as you have questions, but you said you only get one shot. But it sounded like you had more than one shot, because it sounded like the feedback that you got initially for your first plan before your pivot was like it wasn't going to work. I think you actually went kapoo, or kaplam, or whatever that noise is.
It's like, I could wrap it up now and just fold it.
So when you had to come out again and pivot, who did you get the opportunity with again? Was it the same people? Was it different people that you had to sell to?
For the base station, it was same people. But this time I repackaged, right? I identify what the problems that they were anticipating. And I said, I solved this problem with the test and measurement company that you're using to test your radio. So I had some proof point with some credibility.
Yeah, I think that that's actually really important, that you demonstrate that you hear somebody and you're a person that asks questions. I think for advisors, that is a sure sign of someone they want to invest in, because it means you're listening. And for people who are purchasing or looking to buy a product, to have somebody go back and come back with something that they want is pretty huge.
Yeah. So that's the thing, is that I wasn't just listening to the GMs of a company. I was actually listening. I actually went to a production line in a factory with a suit there because I wanted to know how they were testing. And they were telling me about their yield issue, and they were asking me, what can you do to improve the yield, improve the testing time? And I was listening to the test engineers. I spent a day there.
Yeah.
And they appreciated it.
Where was the factory? Where were the factories? Just curious.
That factory happened to be in China. So I was there all day listening to the test engineers.
You said you're a first-time founder. You mentioned the fact that you happen to be a woman. I am curious. I mean, there are a lot of people from China and have a lot more experience than I certainly do, but how was that being a woman CEO or founder in China? How did you navigate that? Any issues or challenges?
It is a challenge, actually, not just in China, but in USA. It's, I mean, I hope 8 years later it's not as bad, but it was a very big problem because it's, you know, the risk is about having lots of data points, right? That's kind of how AI does too. I have lots and lots of proof points. There aren't very many proof points simply to go back on to say that, yeah, if I invest in this type of person, I'm going to be guaranteed to win. Because there is no example like me. So people, it's easier for people to just discard.
So the two partners that were on either side of you, I think when you had I guess when you had the picture taken in the booth,
Yeah.
They're both Silicon Valley, aren't they?
No, actually, Amish is Silicon Valley,
Yeah.
but raised out in Boston area.
Oh, he is in Boston. How, I've heard of Amish. How did you make that connection?
So it's the network effect. Amish knew this person from Bell Labs, and he happened to be my old boss at Bell Labs.
So I don't know if Bell Labs is familiar to you all. It is, but Bell Labs was like the pinnacle of any place to work. In fact, often if you look at people of a certain age, if you look at their background and they have Bell Labs, it's like this stamp of off to great things.
Yeah, we had that back then when we started. And the lab I happened to use was used by this person who won Nobel Prize. And I mean, I have all these terrifying stories when I first gave a talk there, all these people looking at me, right? So,
At the Bell Labs?
Yes.
Oh,
Yeah.
talk about that a little, if you would.
I don't even remember the topic. That's how terrified I was. So, you know, there's a monthly talk you have to give. And usually when the talk notice goes out, it's a picture of wolves because nobody survived that talk. They're all trying to take you down, right? And the talk is just to showcase your latest discovery and research. And people say, have you done this? Have you done that? You know, I've seen this. And so it's a constant attack. So I was very, very nervous. And I put out my talk there. And whatever the reason, right, I was so nervous that I had notes in yellow stickers. And the fan was blowing that all the notes just blew away. So,
But you have it all in here.
so by that, I had no idea what I said, what came of it. But I think people took pity of me. So it was very competitive, vicious. I mean, Berkeley is very competitive, right? It's not vicious, very competitive. So you're very well trained to deal with environment like that.
So it's interesting that you talk about things being competitive and vicious, because here I have a question, not about that much about vicious, but says, the question is, as a woman graduating from college soon, and I think that you can put woman, you can replace that with all sorts of different words, by the way. I feel very anxious about my future and plans to raise a family. How do you balance life, work, and successful business. It's fascinating to have pictures of you with your family up there.
Yes. Yeah, I have gone through 3 graduations during that period, right? 2 graduated from high school, 1 graduated from college. I'm not gonna lie to you that it's not easy. In a way, I would say I was fortunate that I was able to afford a nanny. So that helped. And you have to accept and not feel guilty about getting help. Getting help from your relatives, help from your husband. I didn't have relatives nearby, so it was particularly challenging. Both my parents passed away at my young age. My husband's family are in England. So it was difficult to navigate, but what I did a lot was I planned everything out extremely so I could anticipate what possible problems I may encounter. So that kind of eased some, I would say, pressures that we may anticipate.
Do you think there are more female founders in technology now, so you kind of, somebody has your back a little bit? Do you think things are changing?
Yeah, I certainly see a lot more of that. I'm advising another company who's a female founder, but yes. And so I see that as a great change.
It's hard to imagine that 5 years is not a long time, but 5 years is not that long a time. But if you had to go back to 2016, which doesn't seem that, it's all relative, right? What might you have, the question is, what would you advise yourself when you started with your idea in 2014? I guess that's, sorry, if I could do math, that would be a little bit more helpful. I guess that's 7 years, 8 years.
What might have done better? I think I would have learned about markets a little better. So that's what I'm doing is at this time, although technology is important, I am putting a lot more weight on the markets, the customers, the government regulations, all the things that can make whatever you want to bring out to market a problem. You cannot do anything about geopolitical issues. But anything else you think you need to know and control, you should go and find out, right, beforehand.
So since you did bring it up, I mean, it's I thought it was a tough time. It just gets harder and harder every day. I'm curious to know from a non-personal perspective, but more like a business perspective, how does something like the war or COVID impact your business?
So I would say certainly the situation with China did not help us at all. And so that's kind of the mini pivot, right? So you cannot just rely on banking on particular customer. You have to have multiple customers going, which is very tough if it is dominated by 3 or 4 major behemoths. And then we had to also tackle these other mobile phone area, which is also dominated by 2 behemoths or 3. And then there's like the side ones that you can tackle, like satellite. So that's why we were looking at more than one markets. So, you know, the beauty of fundamental technology is that you can apply to more than one, but now you have to figure out how do you manage how much you can spread. Otherwise you go crazy, right? And then you have to also explain how much investment am I going to make in terms of developing all these engineering resources, because that's your major expense, really.
So you had 2 PhD grads who are working with you. Oh, yeah, please. Do we have a microphone? Yeah. Do you mind also just introducing yourself so we have some context for you?
Yeah, great. Thank you. So, hi, I'm Franklin. I'm a
Hi, Franklin.
junior here at Berkeley. Currently, I'm starting up NeuroExcel. It's basically a semiconductor company trying to accelerate neural network inference.
Oh, great.
I'm going to make you put it even closer to your mouth.
Okay.
Yeah.
Yeah. So there's that, and I looked at your story and I saw a lot of commonalities between like what are the difficulties I'm facing. There's a bunch of behemoths that I'm trying to sell to, and so the first question is that you guys initially tried to use FPGA instead of taping it out. I'm curious, like what are the benefits, pros and cons in terms of FPGA versus taping out for your customers, and then the second question is like, how do you go out and find your first customers as a semiconductor company? Because I feel like that's radically different than a software company. Thank you.
Do you mind repeating the question? Because I don't know, but maybe I'm like, is it hard to hear?
Yeah, I'll repeat the question and let me know if I understood you correctly. So you are working on a startup, building an inference engine based on your neural nets, right? So it is a chip company that you're trying to get off the ground. And your question is there a benefit of starting from FPGA versus going directly to ASIC? And how do you approach a big company who will trust you and believe you, right?
Yes.
Exactly. All the tough ones. So if you remember, I started with software, right? That I can run in CPU, because it's not because that gives you the highest revenue, no. And you can never tell your investors that that is your end goal. I went there because now I had to reset, and I'm trying to prove that this algorithm actually works, that it is of value, right? That it's solving a problem. So that's why I started with software. That software, once you write it in such a way, it is implementable in FPGA. Now, when you rewrite it into an FPGA, you have to write it in such a way that it will run in real time really quickly. But at least it doesn't take 18 months like a chip. FPGA, depending on how skilled you are, could take 6 months to 9 months.
Yeah.
It's just the verification takes a long time, right? So at least you could take that and go to customers and show and do a demo. That's the reason you're doing that. And usually it's much more expensive, so it's not for large volume. But when you are at the cusp of new technology, it's very important to catch the attention and show, right? Prove. That's the reason.
Got it. Great. Okay, thank you.
Now, how do you get to that behemoth? How do you get to all those name brands? From my investors. I did get help from the person who was the VP of sales, who knew the industry. So you need some connections and introduction. But you're on your own after that. Now you have to go and constantly engage, because they will not tell you. They'll tell you all sorts of random problems. Then you have to get to the point of the real problem, right? That's a long process. And that's why I travel so much, to understand the problems. Because it's not that it's some CTO goes there and just listens, right? Or it's not that the business development person goes and listens, or salesperson goes there and sells it. When you are starting a brand new technology, it's you. You have to explain the whole aspects of the technology to business value.
Who do you reach out to? You just mentioned, like, the head of sales, or who's the first touch point?
The very first person, you need a business development person who can actually find the right person to contact at this big company, right? Whoever that you're trying to reach. Once you make the introduction, you have to give it an overview about what is the value that you're bringing to them. And then they'll start asking questions, right? And then you can say, yeah, this is what we're trying to do.
Okay, yeah, great, thank you.
Do you mind passing the mic? Was that a question or a stretch? Oh, no, I guess not. Yes.
Thank you. Hi, Dr. Kim. Thank you so much for coming. I'm also one of the non-technical folks in the room. My name's Jack, but I am really interested in startups and venture capital. And I know in that realm, paying it forward and giving advice is really valued. I believe you mentioned a second ago that you have recently started advising a younger founder, which I think is super cool. What's it like now being sort of on the other side of that ecosystem where you're now the one giving advice, and how has your experience with all those early days pivoting impacted the way that you pay it forward to younger founders?
So what I do is, I guess I explain various examples, encounters I had, because it's also important for the founder to experience themselves, right? Because if I just say things, it actually doesn't resonate very much. So we have to be on the same wavelength. So if that person is coming up with a particular problem, then I have to say, am I understanding the problem correctly? And oftentimes, let's say, the first question usually is about a market fit. So when you first start, you have this very big picture of market, right? Whether it is automotive or whether it's a cloud or whatever the market is. But that's just too big, right? So how do you get to the small segment that you can actually say, this is the very first market, the customer that I'm gonna solve the problem for? And I think that translation is very difficult. I mean, it was difficult for me. So we spend a lot of time talking about that, actually.
Hoping that someone's got another question out there. Awesome. Up front here. Or, I don't see any. Yeah, go ahead, somebody here.
Sorry, I'm just gonna go first since the mic was handed, but hi, my name is Poupée. I'm a undergraduate second year studying psychology. And I mean, you've talked about your experiences, how like you're an Asian woman in STEM and you had so many obstacles you faced along the way of like paving your way to business. I was just wondering, like, with all these like criticisms and doubts, like what kind of drove you to keep going and to keep finding the answers? I guess like your purpose to do all of this, knowing that you're a very like knowledgeable woman.
So what did I didn't hear the last part.
Like your purpose or like drive into why like you are who you are today.
Your life story. Actually, you are like, persevere is not just a word for you. Like, what is it that makes you, what happened in your life you think that made you this, take not the easy road?
Well, I don't know, but there's a saying in Korean that tiger leaves the skin, but people leave their names. So I was kind of brought up that way.
Can you say that again? The tiger
leaves their skin when they die, but humans, they leave their names behind. So I heard that a lot when I was growing up from from Korea. But when my mom was alive, she did have an expectation, and not just from her son, but also from her daughter. She also wanted to break that barrier because she was told not to work when she got married and give up her journalism. So it's really about, how much can you do to continue making that progress. It's kind of what was always inside me. It was certainly not about money, right? There are easier ways to do that. So it's really about what can I do something that is meaningful, is what really kept continuing going for me. And I would say it's very tough, right? I lost my parents when I was in high school. My mother and then later on my father. So there are many ways you could say I can't do that, but somehow I managed to get up and say, I'm going to do it again.
You have two brothers
Yes.
who happen to have gone to Cal.
Yes.
I'm curious, what are they doing?
One of them is a dental surgeon restructuring teeth. The other person who studied actually mechanical engineering and moved to North Korea. He made some money here and decided to donate and dedicate all the money, and he restored this village at the border of Russia and China, and he's in the North Korean region. So he brought in wind power, internet, and goat farming, salmon farming, and some sort of way for them to survive and continue.
How interesting that all of you all are doing such different things, but such things that impact people so much. I know there's a question over here, and I'm going to go ahead and post at least 2 questions. But during that time, I'm going to go ahead and post our code, so you all will have it. So please feel free.
Great. Thank you for your presentation. I have a technical background. I really identify with your story. I'm trying to launch a technology that could give a competitive advantage to the earphone manufacturers. And my question is, when you had to pivot because your potential customers told you that they didn't want the chip, just the algorithm, didn't you consider to commercialize some kind of license so the hardware goes on their side?
So actually, this algorithm is in a chip.
Do you mind repeating the question?
Oh, so I think his question was, you're working on a technology for hearing, improving the hearing, and he was asking, why did you not work on the hardware, right? Well, I started that way. I tried to make a chip, but the investment would have been upwards of $100 million. So now you can imagine, right? Somebody who's trying to get some VC money, you would have to lose a lot of your shares. So the return may not be great, even if you make the chip. And then I also looked at, right, the potential customers, and they said, I don't want your chip. It'll take, 10 years. So if I have to invest, I have to find investors who will invest for that long. So instead, I went the other way. I said, okay, I see that they value these algorithms. I'm going to package it. I'm going to put this into a chip, their chip. So I deliver this as a virtual chip, an IP that they can integrate into their chip. Now, we are doing that also at MaxLinear into a chip. So yes, at the end, it is inside a chip that goes in the radio. You can't just run algorithms without chip, right? So.
Thank you.
Thanks. I think there was one more question that we had. Did I missee? I actually do have one more question for you because you're talking about books so much. Knowing what you know now, Jeffrey Moore's book is a little bit older, but what would you recommend that we read?
The latest book that we would read about business?
It doesn't have to be about business, but yes.
Actually, if it's not business, the book that actually surprised me the most, I think his name is McKay. It's about healthcare.
Oh.
The serious problems of U.S. healthcare.
Has anybody read that, McCabe, Serious Problems of Healthcare?
I'll tell you I don't remember the exact name, but it tells you about the healthcare systems, why some people are overpaying.
So interesting.
Yeah.
Well, I'll send that out. But in the meantime, I want to thank you so much for your time. The students, thank you. We'll have feedback for you.
Thank you.
And just like we always have, if you have extra questions for Dr. Helen Kim, you're welcome to come up toward the stage, or Helen will be here.
Yeah,
and thank you for your time, and good luck on everybody's exams continuing.